This is the 17th episode of our Chinmaya Algebra series, and for this question, we're looking for x minus y quantity squared plus y minus z quantity squared and z minus x quantity squared, given that the sum of x, y, and z is 22, and xy plus yz plus xz is equal to 35. This is pretty standard since we are given with squares and the sum of the variables as well as the sum of the products taken two at a time. To do this, we just have to expand the required expression as x squared minus 2xy plus y squared. So that's the first term. Then add y squared minus 2yz plus z squared. That's the second term. And then lastly, we expand the third. That's z squared minus 2xz plus x squared. If we add the 3 and then group the squared, we get x squared plus y squared plus z squared minus, we factor out the negative 2, minus 2 times xy plus yz plus xz. This xy plus yz plus xz here is known already, so we can just plug in the value of that later on. However, this x squared plus y squared plus z squared is not known yet. But we have a method to determine its value by making use of the identity that x squared plus y squared plus z squared is just equal to the square of x plus y plus z minus 2 times xy plus yz plus xz. Actually, going back, this is not just x squared plus y squared plus z squared. This is in fact twice that sum because we have 2x squared in the sum, 2y squared, and 2z squared. So actually this is just 2 times x squared plus y squared plus z squared. Anyway, going back to this sum here, sum of squares, is just equivalent to the square of the sum minus 2 times xy plus yz plus xz. So if we substitute it here, and then we call this, let's call this sum as s, and let's call this as p. So the required expression is actually equal to 2 times s minus 2p minus 2p. Simplify this, we get this is s squared, 2s squared minus 4p minus 2p, or 2s squared minus 6p. Substitute the value of s, we know that to be 22, and then p as 35. This is 2 times 22 squared minus 6 times 35. This is 2 times 22 squared is 484. And then 6 times 35 is 210. Let's just simplify this. This is 968 minus 210. Simplify this difference, we get 758. And that's our final answer. So again, just a recap, what we did is we expound the three squareds and then rewrite them by combining into the sum of squares and then twice the product of xy plus yz and xz. Finally, we use the identity for the sum of squares and simplify the result. So the answer here is 758. Hope you learned something from this video. Thank you for watching and please subscribe for more content.